Alright, hi students, this is a quick guide on how do you calculate relative atomic mass, known as AR, as well as relative molecular or relative formula mass, known as MR, and how do you then use that to find the number of moles of the chemicals. Now, before we can go with this concept, I think it's important for you to make sure that you have a periodic table with you, because you realize that you need your periodic table for this entire set of calculations, right? So get your periodic table ready. First, I just want to highlight that whenever you're finding out about the relative atomic mass, AR, or the relative molecular mass, MR, of the chemical, you always start first by using a periodic table to find the element. Then, look at what we call a mass number, count how many atoms are there, and then add up their masses. Let's take a look at one example together. Let's use the chemical of magnesium carbonate as an example. So based on this formula, you should be able to see that there is this chemical called magnesium, there's this chemical called carbon, and there's this chemical called oxygen in the periodic table. So what do we do then is we go to the periodic table, we look for the chemical magnesium, and you can see that magnesium is over here highlighted in pink. And you realize that there's two kind of numbers, one at the top and one at the bottom. You'll remember that in class we mentioned that you can use this P in your periodic table. It's like a legend. It helps to tell you that the number at the top is what we call a proton number. So you have been using this all this while when you're doing your dot and cross. And the number at the bottom is what we call the relative atomic mass, or I'll just use AR as a shortcut. So this means that for one magnesium, the mass is 24. Right? So we go back to our question here. That means for each of the magnesium here, we now know that the mass is actually 24. Then we look for carbon. So in the periodic table, carbon is the one that's highlighted in green here. And you can see that similarly the number at the top is a proton number, which we don't need it for this calculation. But the number at the bottom is our AR, we should be using it. And likewise, for the last one, which is oxygen, highlighted in yellow, we'll need the mass of 16 below. Now all these masses is important because we'll then use it to calculate the overall relative molecular mass or relative formula mass of the chemical. So what do we do now? Start first by counting how many atoms are there inside this formula. So you should be able to see that there is one magnesium, there is one carbon, one because there is no number over here next to the chemical symbol, and there are 3 oxygen because you need to factor in the 3 multiplying in to show that there's 3 sets of oxygen. So now that you have this thing, right, you can count and see that actually to find the mass or the MR, you'll be equivalent to find one magnesium, which is 24 just now, one of the carbon, which is 12 just now, and there's 3 of the oxygen. So you should use a 3 to multiply by 16 because each of the oxygen is actually 16. Do take note that you're supposed to add up the numbers, not to multiply the numbers. Right? That's not what you need to do. You should be adding up the numbers by themselves. If you are having issues with this, you can also write out 16 plus 16 plus 16 if you are scared that you'll be careless. Right? But other than that, I think most of you should be fine. Just make sure when you key in the calculator, you make sure you put in the bracket, make sure you put in the plus, and count carefully, double check your answer. Right? So if you add up the entire thing together, maybe you can key in the calculator now and let me know how much is the relative molecular mass. Right? And you should be able to find out that it's actually 84. So that will tell you what we call a relative molecular mass. Now, the next part of this video is that I want to highlight how do you find then the number of moles. Right? Moles is a bit more unique. Moles requires you to know about this formula called mole is equals to the mass of a chemical in terms of grams divided by the AR or the MR of the chemical. Right? In short, there's a triangle that we can use, and this triangle is similar to those of you who take physics. You should be able to know that the triangle allows you to have a clearer idea of what is on top and what is below when you're doing a calculation. For instance, you might be asked to find out what is the number of mole of 2 grams of MgCO3. Now these 2 grams So I'm just going to zoom into the formula here. These 2 grams of MgCO3 will refer to the mass at the top of the formula. But where do you get this AR or MR? That's where you use what we calculated just now to go and look out for what is the number based on the periodic table, add it up based on the number of atoms, and then you use it and apply it in this formula. And this should tell you that it will be equivalent to 2, which is 2 grams, divided by 84. And then this should give you your answers. So similarly, key into a calculator and let me know what's the value that you get. Yep, and if you key in correctly, you will get actually a long running number. So let me shift some of these things away so that we have more space to look at what exactly is the number. When you key in the calculator, you should end up with 0.023809552, etc. This will be a very long set of number, but you must remember that in chemistry, when the number is like this, we always simplify it to just a 3 significant figure. So what's a 3 significant figure here? 0.0 will stay. Then we look at the next 3 very important numbers, 2, 3, and 8. Because after 8 is a 0, so we can just round down and it just become 8. Then this will be your answer for the number of moles. Right, we're trying to apply this to the next few questions using the end of year paper as an example. Then you can see how can you apply your MR calculation and your mole calculation to score for such questions. Let's take a look at 2022's end of year paper. So this is 2022 end of year paper. The question is asking the student to calculate. At the end of an experiment, there's 19 grams of a magnesium chloride, MgCl2, and they're supposed to calculate the relative formula mass of magnesium chloride, which is MgCl2. So MR means before I calculate, we need to know that inside MgCl2, there's 1 of the Mg and there's 2 of the Cl. Yeah, so then we'll go to the periodic table, look for Mg, like I mentioned just now. We'll know that this is the AR that we want, which is 24. Look for chlorine, which in this case is the one in the yellow, the pink highlight. You know that this is the relative mass that we want, which is each of them is 35.5. So coming back to our paper, this will mean that it's 24 plus there's 2 of the chlorine, so 2 times 35.5, and it should be ending up with 95. Do note that MR has no unit, right? It's just a relative formula mass. It has no unit. Just add up the mass number and that will be enough. Then you're supposed to calculate the number of moles, right? So moles, similarly, get the formula out. Mole is mass in grams divided by AR or MR of the chemical. In this question, the grams that's given to you is at the top. It's 19 grams. So you want to read the question so that you can use the information, right? And be careful when you read the question to see how is the mass being presented. And that'll be 19 divided by 95. And that will end up with 0.2. And make sure you leave your unit here, which is in terms of mole, right? So that is 0.2 mole. Right, I hope you're getting the hang of it. We'll take a look at one last paper from 2023 to see how to apply this formula. In 2023's end of year paper, right, we just focus on 4b. Right, you're supposed to calculate the relative formula mass of this chemical Ag2SO4. So similarly, look at it. You should know that there's 2 Ag, there's 1 S, and there's 4 of the O. Right? The good thing about this question is that they actually give you the mass at the bottom here. So you don't even need to use the periodic table. You could just look at the mass here. Silver is Ag, so it's 108, which is this one. One of it is 108, one of it is 108. Sulfur is 32, which means that one of this is 32. Oxygen is 16, means one of it is 16. The other one is also 16, the other one is also 16, the other one is also 16. So how do you find the MR over here? You will have to add up 2 sets of 108, because there's 2 of the Ag, 1 of the 32, because there's only 1 of sulfur, plus 4 sets of 16, and then we punch into a calculator carefully to make sure that we put in the bracket, we don't mess up the numbers, and you should end up with 312. No unit. MR has no unit. Next question, find the number of moles. So mole formula is mass in grams over either the AR or the MR of the chemical, right? And this will be equivalent to the mass we'll take from the question here. The question says that there is 78.0 gram. So take 78 divided by 312, and you should end up with 0.25 mole here. Right, hope this is helpful. Try to revise and understand how do you use this formula. You can take a look at the notes, take a look at all the practice questions that we've been going through. Thank you.